I attempted to rebuild a broken gearbox on my Veyron without Bugatti's help. After rebuilding this amazing car and driving it for the first time, we sadly found out we still have a few problems. The new clutch that we had replaced was slipping.
Picture this. You spend 6 months and a small fortune taking apart one of the rarest cars on earth, a Bugatti Veyron, piece by piece, in a small workshop with no help at all from the factory that built it. You put it all back together with your own hands, tightening every bolt, checking every seal, doubting yourself at every single stage of the process. The engine fires up on the first try. The gearbox moves smoothly on the bench. Everyone standing in the room lets out a breath they didn't even know they were holding, because this exact moment felt almost impossible just a few short weeks earlier, back when the car was still lying in scattered pieces across the workshop floor. Then, finally, after months of waiting, you drive the car for the very first time since the rebuild truly began, and within just a few seconds, something feels wrong. Not a small wrong, not a strange little noise you can simply shrug off and ignore. A deep, gut drop kind of wrong, the kind of feeling that makes your stomach turn before your brain even finishes forming the thought. The clutch is slipping. After half a year of careful, patient work, thousands of hours spent bent over engine bays and gearbox casings under bright workshop lights, and a car worth close to £1 million sitting quietly on the line, the whole team is now staring down the very real chance that all of it might have been wasted completely. This is not simply a story about a car that broke once and then got fixed in a single quiet afternoon. This is a much bigger story about a car that kept fighting back again and again, testing the patience, the skill, and the nerves of everyone who ever touched it. It is a story about oil, about heat, about tiny computer chips that quietly learn on their own without ever being directly told to, about screwdrivers kept tucked away in back pockets for sudden emergencies, and about a machine so strange and so advanced that even the people who originally designed it 20 years earlier could not guess every single way it would eventually challenge the humans trying so hard to bring it back to life. By the end of this long and winding journey, there would be a locked door with seemingly no way back inside, a rear wing that stubbornly refused to sit at the correct angle, a fault code appearing with no warning light anywhere to explain it, and finally, a full valuation delivered by 3 separate experts who had personally watched this entire wild ride unfold slowly from start to finish. But it all begins with one simple, sinking feeling inside a quiet workshop late at night. The car is finally moving proudly under its own power again after so many months, yet it should never, ever feel anything quite like this. Every single person standing in that workshop knew, deep down, exactly what a bad slipping clutch felt like, and this was clearly it, plain and simple, no matter how much anyone hoped otherwise. There was no easy way to pretend the problem away, no simple wipe of a rag, or quick tightening of a bolt that would make this particular feeling disappear. 6 months of long nights, missed weekends, and careful decisions had led to this single, quiet moment behind the wheel, and now everyone had to face the very real possibility that something fundamental still needed to be understood before any real celebration could begin. What follows in this story is a full account of how a small, determined team chased down the actual cause of that slipping feeling, tested wild theories late into the night, leaned on decades-old engineering knowledge, and slowly, patiently coaxed one of the most complicated cars ever built back into proper working order, one careful step at a time that don't understand why the single moment mattered so deeply. You first have to understand everything that came before it. The Bugatti Veyron is not an ordinary supercar, and it never was meant to be. It is often called the very first true hypercar, a machine built in the early 2000s to do things that no road car had ever managed to do before. It could reach past 400 kilometers per hour, a speed that still sounds unbelievable today. It packed well over 1,000 horsepower into a shape that you could technically still drive down to the shops for milk. Fewer than 500 Veyrons were ever built in total, and every single one that left the factory carried a level of hidden complexity that most garages, and honestly most trained mechanics, would never dare to touch with their own tools. So when this particular Veyron arrived at the workshop with a badly broken gearbox, the obvious and easy choice would have been to send it straight back to Bugatti and simply pay whatever enormous bill they decided to charge. Instead, the owner chose the much harder path. He chose to strip the entire car down himself, working alongside a small, dedicated crew of engineers and mechanics, and rebuild the very heart of the machine completely without the manufacturer's blessing or support. This meant tracking down parts that Bugatti flatly refused to sell to outsiders, carefully reverse engineering original components by hand, and in some cases building entirely new pieces completely from scratch, including a brand new clutch material that did not officially exist before this project began. 6 long months of careful, patient labor went into putting that gearbox back together the right way, piece by piece, bolt by bolt. Everyone involved understood the risk hanging over their heads the entire time. If something went wrong, the car might need to be split apart all over again, undoing months of slow, expensive progress in a single frustrating afternoon. So when that very first test drive revealed a slipping clutch instead of the smooth, confident drive everyone was hoping for, it was never just a small mechanical hiccup to shrug off. It felt like the exact moment the entire gamble might quietly collapse. The tension inside that workshop was not about some odd noise or minor rattle somewhere in the cabin. It was about whether half a year of relentless effort and an enormous amount of money already spent was about to be wasted on a single problem that nobody in the room could yet properly explain. Every decision made along this long journey carried real weight, because there was simply no cheap way to test a wild theory and quietly walk it back if it turned out to be wrong. Ordering the wrong replacement part or misreading a single sensor reading could easily cost a team weeks of extra work and thousands of pounds in wasted material and lost time. And yet the team pressed forward anyway, driven partly by stubborn pride and partly by a genuine deep love for a car that most ordinary people would only ever see in glossy photographs or hear about briefly on television. They were not simply fixing a rare machine for a paycheck at the end of the week. They were quietly trying to prove that even a car built with almost limitless factory resources and unlimited engineering budgets could still be properly understood, respected, and repaired by a small group of passionate, ordinary people working with far more modest tools, and only a tiny fraction of the original manufacturing budget behind them to make real sense of the slipping clutch. The team called back in Rob Barnes, a gearbox specialist who had actually helped design the original Veyron clutch and gearbox system all the way back in 2006. Rob was genuinely one of the very few people on the entire planet who understood the specific piece of engineering from the inside out, having literally helped invent it decades earlier. His first diagnosis, delivered calmly but clearly, was blunt and direct. The car had what he called clutch lift, meaning that as a driver tried to pull away gently from a complete stop, the engine had to rev far higher than normal, simply to force the clutch to disengage properly and let the car move forward. Something about this new clutch was clearly not behaving the way the original factory unit had behaved decades earlier. The team already knew going in that the new clutch was not a genuine Bugatti part, mostly because the manufacturer flatly refused to sell them one at any price. Instead, an expert named Pascal had carefully taken the old, badly worn clutch completely apart, studied every single surface closely under bright light, and then built a brand new replacement based entirely on what he found during that inspection. But when Rob compared the two clutches side by side on a workbench, real differences jumped out almost immediately, even to an untrained eye. The original clutch material leaned heavily on paper-based construction, with only some carbon content mixed in for strength, while the newer replacement leaned much more heavily on pure carbon material throughout. Even more telling were the small grooves and cutout patterns carved into the surface of the original plates, patterns that were simply missing entirely from a brand new replacement clutch. These were never just small cosmetic details either. Every single cut and groove on a clutch plate exists for a very specific reason, usually to carefully manage exactly how oil moves across the surface during hard operation. Rob patiently explained that the original design relied on an extremely careful balance, allowing a genuinely huge amount of oil, more than 32 liters every single minute, to flow through the clutch assembly to control rising heat, while still leaving enough dry contact area for the plates to grip properly and transfer power. Get that delicate balance even slightly wrong, and the entire system starts behaving completely differently, even when every single individual part still looks correct sitting on the shelf. This is exactly why simply looking at a clutch, even holding it in your hands and turning it over under bright light, does not tell you everything you truly need to know about how it will actually behave once bolted back into a working gearbox under real load. A part can appear flawless, perfectly machined, and still fail to do its job properly if the tiny surface details do not match what the surrounding system expects to see and feel. Rob's years of hands-on experience meant he could spot these subtle differences almost instantly, simply by holding both clutches side by side and running a fingertip carefully across each surface. It was a kind of knowledge that cannot easily be written down in a manual or looked up online. The sort of understanding that only comes from actually building something with your own two hands decades earlier and remembering every small detail about why each choice was originally made. Without someone like Rob standing in that workshop, the team could have easily spent weeks chasing the wrong theory entirely, replacing perfectly good sensors or wiring while the rail, cause that quietly overlooked, hidden in the fine texture of a clutch plate surface. This is often how the hardest mechanical problems actually get solved in the real world, not through guesswork or trial and error alone, but through someone bringing decades of hard-earned, specific knowledge directly to the exact problem in front of them at exactly the right moment. The real breakthrough in understanding the strange problem came when Rob explained it using a simple, everyday comparison that literally anyone could easily picture in their head. Think for a moment about driving a normal car on a completely dry road using tires that only have a few shallow grooves cut into the rubber tread. On dry tarmac, those particular tires actually grip beautifully well, with plenty of confident traction under acceleration. But now spray a good amount of water across that exact same stretch of road, and suddenly those same tires start sliding around helplessly, because the rubber is now riding on top of a thin layer of water instead of properly touching the solid road surface underneath. This everyday phenomenon is called hydroplaning, and it turned out to be precisely what was happening deep inside this gearbox. The oil constantly flowing through the brand new clutch was simply not escaping fast enough through those missing grooves. So instead of gripping firmly, the clutch plates were essentially floating on a thin, invisible film of oil in almost exactly the same way tires float helplessly on standing water. That single explanation cleared up why the engine needed so many extra revs just to get the car creeping forward, and why the clutch felt vague and slippery instead of sharp, direct, and confident. Pascal had clearly understood the original cutting pattern perfectly well when he first took that old clutch apart for inspection. But modern clutch materials used inside today's dual clutch transmissions are manufactured completely differently than they were built 20 full years ago. Pascal's particular version of the clutch material had already been proven to work extremely well inside other high-powered dual clutch gearboxes, comfortably producing huge amounts of horsepower without any issue whatsoever. The real problem was that the specific Veyron gearbox, with its unique, aging 20-year-old internal design, simply was not built with this particular newer material anywhere in mind when it was engineered. It left the entire team facing one genuinely difficult question. Was there some clever way to make this new clutch material properly work inside an old gearbox that had literally never encountered anything quite like it before? Or would the whole car eventually need to be taken apart again from scratch to try a completely different approach entirely? Nobody in that workshop wanted to say the second option out loud, because everyone already understood exactly what it would mean in practice. It would mean unbolting parts that had only just been carefully bolted together. It would mean draining fluids that had only just been carefully filled. It would mean weeks, possibly months, of additional labor stacked directly on top of the 6 months already spent, with absolutely no guarantee that a second attempt would even turn out any better than the first one had. So instead of jumping straight to that painful conclusion, the team chose to slow down, breathe, and think carefully through every smaller option available to them first, trusting that somewhere in the car's own design there might already exist an answer nobody had fully considered yet. This kind of patient thinking is often what separates a rushed, expensive repair from a smart, lasting one. Anyone can throw new parts at a problem and hope for the best, but genuinely understanding why a system behaves the way it does takes real discipline, especially when the clock is ticking and everyone involved is desperate to simply see the car finally driving properly again after so many months of waiting. Rob calmly offered 2 very different possible paths forward, and honestly, one of them was genuinely frightening to even consider out loud. The first option involved designing an entirely new version of the clutch material from the ground up, essentially starting the whole engineering process over again from scratch. That would almost certainly mean splitting the finished car apart once more, a lengthy process that had already consumed enormous amounts of time and money the very first time it happened. Nobody in that workshop wanted to hear that particular answer spoken aloud. The second option, thankfully, was far more hopeful, and it hinged entirely on something genuinely clever that had been quietly built into the car's original software many decades earlier. Even though the clutch's basic torque and pressure map inside the computer could not simply be changed or edited by hand, the transmission software still contained something called an adaptation system. This clever system was originally designed to account for small, natural variation between individual clutches coming off the production line, allowing the car's onboard computer to automatically fine-tune exactly how hard it needed to push the clutch plates together to get engine power moving smoothly out to the wheels. In simple, plain terms, the car's onboard brain was currently confused about what it was dealing with. It had been carefully taught years earlier to expect a clutch with a certain feel, a certain thickness, and a certain surface material, and absolutely none of that matched what had just been freshly installed inside it. Rob's working theory was that the car might simply not be pushing the clutch plates together hard enough yet, which meant the oil was quietly pooling on the surface instead of being properly squeezed out from between the plates during operation. If the software could somehow be gently encouraged to increase that internal pressure gradually, purely through its own built-in learning process, the oil might finally get forced out much faster, restoring proper firm grip, without anyone ever needing to physically touch or rewrite the transmission's actual underlying code. Nobody on the team could access that internal software directly to reprogram it by hand in the first place. So the only realistic path forward left was to patiently let the car quietly teach itself, slowly and carefully through deliberate, controlled driving. There was something quietly humbling about this whole situation, honestly. Here sat one of the most powerful, most extreme road cars ever built, and the solution to its biggest remaining problem did not involve more horsepower, more carbon fiber, or more expensive parts at all. It involved patience, careful driving, and trusting a small piece of software written by two engineers working together decades earlier, long before anyone in that workshop had even met the car in person. It was a genuine reminder that sometimes the cleverest fix is not the loudest or most expensive one, but simply the one that was quietly built in ahead of time by people who understood the machine well enough to plan for exactly this kind of uncertain future. Good engineering often works exactly like this, quietly, invisibly, and years ahead of when it is actually needed. Nobody in 2006 could have known exactly which future clutch material this car might one day need to adapt to. Yet the adaptation system was built flexible enough to handle that uncertainty anyway, simply because good engineers tend to plan generously for problems they cannot yet fully picture. Putting this clever theory into real action meant something almost comically simple in practice. There was no fancy dashboard menu to click through, and no laptop plugged directly into a diagnostic port anywhere. The actual plan was simply to sit the car completely still, let the engine and transmission slowly warm up to one very specific target temperature, and then have the driver do absolutely nothing at all for a short while. If the gearbox reached the correct internal warmth, roughly 40 degrees centigrade, and then stayed steady there completely undisturbed for about 30 full seconds, the onboard computer would automatically begin quietly adjusting itself in the background, carefully hunting for the correct pressure points across both clutches at once. This entire hidden process had actually been written into the car's software over 20 full years earlier by Rob and his colleague Andrew, a kind of hidden safety net designed to let the gearbox protect and correct itself naturally over time as parts gradually wore down through normal use. Watching this happen in real time felt genuinely strange, almost quietly magical to witness. The team gathered closely around the dashboard as the engine calmly idled away. The shaft speed readout slowly shifted on the small screen, and the software patiently began teaching itself how to properly work with completely different clutch material than it had ever encountered before in its entire operating life. It was a strange, almost peaceful kind of relief, watching simple numbers quietly change on a small display instead of hearing tools clanking loudly against cold metal, knowing the slow, patient computerized process might succeed exactly where brute mechanical fixes clearly could not. There was even one small moment of genuinely dark comedy woven into choosing who would actually sit inside the car for this first delicate test, since one of the doors was not working properly at all, which meant simply getting in and back out again required real physical effort and patience. A quick, light-hearted game of rock, paper, scissors settled the whole matter fairly, and soon enough, the numbers on a little display began shifting almost exactly as everyone had quietly hoped, suggesting the clutch might genuinely be relearning itself correctly from this very first careful attempt. It was a strange contrast, watching a nearly million-pound hypercar sit perfectly still in a workshop, while grown adults settled who got to sit inside it using a playground game normally reserved for children arguing over the last slice of pizza. Yet that small, silly moment captured something important about the whole project. Despite the enormous stakes, the huge sums of money involved, and the genuine stress everyone had been carrying for months, there was still room for laughter, for teasing, and for simple human moments between people who had clearly grown close through shared struggle. Those small, light-hearted breaks mattered just as much as the technical breakthroughs, because they kept everyone sane through an incredibly long and often frustrating process. Long projects like this one tend to wear people down slowly, not through one single disaster, but through the steady accumulation of small setbacks stacked one on top of another. Having people around who could still laugh, still joke, and still find humor in an awkward broken door handle made the whole experience far more bearable, and arguably helped everyone think more clearly whenever the next real problem eventually showed up out of course. Teaching a stubborn gearbox to properly trust a brand new clutch material takes considerably more effort than just 30 seconds of quiet idling in a workshop. The next stage required Rayall driving out on actual roads, holding perfectly steady speeds and steady engine revs in each individual gear for roughly half a minute at a time, giving the onboard software clean, consistent data to properly learn from without interruption. The team ventured carefully out onto the open motorway, cycling patiently through the gears one by one, trying hard to hold each target speed just long enough for the hidden system to quietly make its tiny internal adjustments before smoothly moving on to the next point along the chart. Almost immediately, ordinary daytime traffic complicated absolutely everything about this careful plan. Constant braking and repeated stopping meant the software never received the smooth, uninterrupted driving conditions it genuinely needed to learn properly, and there was a real, genuine fear that repeated stopping and starting might actually overheat the fragile new clutch even further instead of gently helping it settle in. So the team made one genuinely smart, patient decision together. Rather than continue fighting frustrating daytime traffic, they chose to wait until midnight on a quiet Sunday evening, when the roads were finally completely empty and a trusted test driver named Matt could comfortably loop around a small local circuit for close to a full hour, holding steady